Okay, let's do one other example. So first thing we need to do is rewrite this as multiplication and then factor. So if you want to pause this and try it and then check your answer. So what you should have done first is kept this first fraction. I guess I could have factored this one since it's not moving, but I'm going to go ahead and just write it like this. Change it to multiplication and then flip your second fraction. I'm now going to factor the numerator. So I need two numbers that multiply to be 16 and add to be 10, and that would be a positive 2 and a positive 8. Now I need two numbers in the denominator that multiply to be 8 and add to be 6. Remember, don't always start from scratch, so it has to be one of these factors in the numerator if something's going to cancel, or this x plus 4. And it looks like it's x plus 4 times x plus 2, because 4 times 2 is 8, and 4 plus 2 is 6. So don't start from scratch. Look at the factors you have to help you factor that one. Okay, now let's cancel. We have an x plus 4 we can cancel and an x plus 2 we can cancel. And all I'm left with is x plus 8, and I sometimes see it written as 1 over 1. And you can write it that way, but you don't, anything divided by 1 is just itself, so really this simplifies to be x plus 8. Okay, we're going to set up a problem with rationals. We're not going to actually be solving it yet, but we do want to set it up. So this example says, in a motorcycle race, one lap of the course is 650 meters. Jenna and Tom start at the same time, but Jenna drives her motorcycle 5 meters per second faster than Tom. Set up rational expressions to show their times. So in math, a lot of times what you're solving for is on the end of the sentence, or excuse me, the end of the problem. So we're looking for their times. So this problem is using distance, rate, and time, and this is distance equals rate times time, or sometimes we say dirt to help us remember it. And you use this all the time, you just might not use a formula. So if you know your average speed and the distance you have to travel, you can kind of figure out how long it would take you. So this is the formula. So when I'm working on a problem like this, I like to set up a table just to help me organize all that information that I'm given. So I have Jenna and Tom, but it could be whatever you're looking at, whether it's a train, a bus. And I'm going to fill in distance equals rate times time. Okay, so for Jenna, I know her distance is the length of the course, which is 650 meters. I leave the units off when I'm filling in this table. And Tom is also 650 meters. Now as for their rate, I do not know their exact rate, but I know Jenna's was 5 meters per second faster. So that means if Tom was r, and I'll just use r since that's a variable we have here, then Jenna's was 5 meters per second faster, means you're adding 5 to Tom's rate. And then for time, I'm going to just say Jenna's time, so t with the lower a subscript g, and then Tom's time, which would be t with a subscript capital T. Okay, so I filled in the table, and I'm just going to write those two formulas over here. So the first one is Jenna is 650, its distance equals rate times time. So just put that r plus 5 in parentheses because it has to stay together. So that's Jenna's. Do this. Tom's time is 650 equals r times time for Tom. Now it says solve for their time. All I need to do is get this variable by itself, t. So this is multiplication. To get t by itself, I'm going to divide both sides by r plus 5. And I get Jenna's time is 650 over r plus 5. Now for Tom's time, I just need to divide both sides by r, and I get Tom's time is 650 divided by r.